So we look at what is the essence of binary, that is base of 2. So a number that is a base of 2 basically has only two values. Right? Like we have a base of 10. So decimal is 10, which means base of 10. Which means number goes from 0 all the way up to 9, doesn't get to 10. So a binary number base of 2 means the digits are only 0 and 1. So let's see how we can sort of make sense of what is the essence of binary, right? So let's say we had a weighing balance. Okay, and here we have different objects, and this side I want to have I want to be able to measure weights from, let's say, 1 to 15, right? 0 obviously nothing, so 1 to 15 kgs or 15 grams or whatever, let's say kgs. Okay, and my constraints are that I can only I can only have I want to have minimum weight, which means minimum number of weights. Okay, so if I want to have only 3 weights or 4 weights or 5 weights, so minimum number of weights. Okay, and minimum mass of the weights. Okay, so if you did, let's say, binary, we would have said, okay, let's have one weight of 10 kg, and then we'll have one weight of 5 kg, and then I'll have weights from 1 to 4 kg, I'm done. Okay, but here I have 1 plus 2 plus 3 plus 4 plus, 5 plus 10, right? That's quite a bit. So of course I can say, wait, I can eliminate, I don't have to use all of these, right? I can say 5 I can get out of 1 plus 4, okay fine, I don't have to do that. But you can't, because really if you need to get 9, how do you get 9? Right? So what is the most efficient way in which you can solve this problem of having every weight from 1 to 15 and at the same time having a minimum number of weights and minimum mass of the weights? So it turns out the solution for this is binary system, which means I have 1 kg, I have 2 kg, I have 4 kg, I have 8 kg. And with these 4, I can get all the weights that I need. When I add all of them, I get 15. So which is the minimum weight, because you have to be able to measure 15, so obviously it can't be less than 15. So this is the minimum weights that I can have, putting it only on one side of the scale, of course, that's the assumption. Putting it on one side of the scale, these are the most efficient weights I can have to get every weight from 1 to 15 with the minimum mass, which is always going to be 15. So if I wanted to have a weight of 1, that's 1 and nothing here. And so why this is a binary system is because you either have the weight or do not have the weight. So the most efficient system will be binary and not decimal. Right? So if I wanted to have 2, I have 2 but nothing else. If I wanted to have 3, I'll have both 2 and 1. So it satisfies everything till then. Right? Then if I have 4, I can't do it with this. Right? I cannot do it with this. I need to go into 1, 0, 0, 0. I have only 4. But when I have 5, I have 4 plus 1. So 5 will be 4. Am I gone off the chart? Yeah. 4 plus 1. 6 will be. So this pattern is going to repeat. 0 is 0th weight, but this pattern is going to repeat. So let's write this down once and see what it looks like. So if we look here, we can see that you have a certain pattern here. Smallest pattern 0, 1, 0, 1 will keep repeating. It's there, it's not there, it's there, it's not there. Right. So that is one pattern that you can see. The second pattern that we can see is if you have 2 bits, the pattern is 0, then 1, then 2, then 3. again 0, then 1, then 2, then 3, and this pattern will subsequently keep repeating. Then if you see the next one, this is the next pattern. This pattern will keep repeating, and so on and so forth. So every time the next digit changes, it's waiting for the entire patterns inside to get over, and only then the next bit comes on, right? And then this is how the pattern keeps building. So it's always consistent. Just like the decimal system is always consistent, the binary system is always consistent with its bits. So that's the first thing we observe. These patterns that keep repeating, you always have to complete something, the number of bits, what can be represented. So that's 0, 1, 2, 3. So 4, 5, 6, 7 is 4 plus 1, 4 plus 2, 4 plus 3, 4 plus, that's 4, I'm sorry, 4 plus 0, 4 plus 1, 4 plus 2, 4 plus 3. 4 plus 4 is not there because the maximum is 4, so then it becomes 8. Yeah. So this is the pattern that we have, and how binary is representing a decimal number. You are seeing how much of that weight is there. Okay. So let's take a few examples, right? So we'll limit ourselves to 4 bits, which means you're limiting yourself to 15. And you say something like, okay, what about 11? How can I get 11? Okay. So first thing you look at is 11 more than 8? That's the biggest weight. If it is more than 8, it needs to have an 8. No other option. Okay. Because otherwise you would have been able to represent with the smaller numbers, but you can only represent up to 7. So 8 is going to be there. Then you need 3 more. And 3 is of course 2 plus 1. So 4 is 0. There is no 4. So if it is 8 plus 0 plus 2 plus 1, it's 1. That's the representation for it. Right? So first we should be able to figure it out with logic. And then we can remember hexadecimal or some of these things as well. So first thing is logic. The second thing is there is a methodology to do that logic, right? So we can just look at that quickly, which everyone is used to, and then we can talk about why does it work. So I divide by 2 and I look for remainder here. Remainder is 1. Then I divide again. So this, what is, if I remove the 1, 5, it becomes 10, you get 5. I divide again by 2. I get a remainder of 1. So that's 4. What is left is 4. 4 divided by 2 is 2. I divide by 2, I get nothing. Then I get 1. The result is 1. And this is the number which is the result. So this is a shortcut that most people know. So that it is 1, 0, 1, 1. So the question is, why does this work? Why does 1, 0, 1, 1 work? Think about it.